Hi everyone. In this video I am going to explain about module. So module is the basic uh, element in your complete Verilog programming. In the VHDL programming there are two different parts are there, like entity and architecture. Entity is a part where inputs and outputs are declared in the VHDL, and architecture is the place where we are explaining completely about the functionality of the circuit, or we can say the relation between input and output variables, that we are going to explain in the case of architecture. So these two parts are in the VHDL programming, but whereas in the Verilog programming such two parts are not there, only single part is there. That part is known as module. Okay, so module is a single entity that is used to describe the input and outputs of the your hardware architecture, and as well as the same module gives the relation between these. Now a place to write the ports and function. Simply a single piece of hardware, you can also say it is a single piece of hardware. It has declarations, it has declarations that describe the names and types of modules, module inputs, modules input, outputs, logical signals, variables, constants, and functions used internally to module. Module contains statements. Module contains statements that specify operation of modules outputs and internal signals. Okay, so module contains statements that specify the operation of module outputs. Okay, in the internally we are using inputs and outputs for the module, so that specifies the operation of the module outputs and internal signals. Suppose there are two different types of modules available, two types of module declarations, module declarations available. First one, single module, and the second one is module instantiating other modules. That means in the single module only this particular module is the whole and sole responsible. Okay, the inputs and outputs are there only in that. But whereas the second type of module declaration is, it is having one parent module consisting of several child modules. Okay, all these child modules will be having interrelation with respect to the parent module. Okay, for example, first one, single module. So single module means declaration statements. We are having one module, declarations statements. This is what a single module, just everything will be there in that particular module only. It does not depend on other modules. And the second type is module instantiating other modules. Module instantiating other modules means you are having one main module or a parent module, like module A, declarations, statements. So in this again we are having multiple module declarations that again calls those modules whenever required. So module B, module C, module E, module E. So module A is the main module. In that we are having all these port mapping modules. See, by seeing this you can understand this particular module declaration is used for structural model of the Verilog coding. In the VHDL coding also we have seen structural model where one main program is there and that program calls the individual programs. Okay, individual component declarations are there. Whenever the component is declared, automatically the program will be connected to that particular component. Here also the same modules. Module A is the main program. In that we are calling module B, C, D, E and so on. Okay, whereas module B, module C, module D, module E, they are having separate programs which are defined earlier by the same user before writing module A. Okay, without having this module A, B, C, D, module B, C, D, E, this module A will not work. That is the meaning of instantiating the other modules. Okay, now the syntax for the module declaration. Syntax for the module declaration is module, module name, module name, port name 1, 2 and so on. We are having number of ports. So ports here we are going to specify what are the input ports and as well as what are the output ports. Everything inside this particular brackets. Okay, so all the inputs and output ports must be declared here. So again you are saying what are the input declarations, output declarations. Suppose y is output, a b are inputs, then a b y you will write a list of variables here, a b y. You are saying input a comma b, output y, like that. Okay, so that after going inside into the module we can understand what is input and what is output. And if any intermediate signal is there required, then in-out declarations are also used. In-out declaration, net declaration, you know very well about net. Okay, net is nothing but a data type. Variable declaration, parameter declaration, function declarations, task declaration, and concurrent statements, and after that end module. Likewise we are having multiple statements. End module, see here how I am writing end module. So end module both must be single word, there is no space between end and module. Okay, and at the same time at the end we don't have any full stop or comma or semicolon, nothing is there. It is end module, that's it. Okay, example module some gate x y z Okay, after that you have to use semicolon. Input x comma y. That means here you are saying what are the inputs, and similarly output z. Assign assign z is equal to assign z is equal to x and y. Suppose some indicate is there. Assign z is equal to x and y, semicolon. After that end module, that's it. So here you are writing in the brackets of the module, here you are writing what are the input ports and output ports available. After that you are specifying what are the inputs, what are the outputs, and then assign statement. This is what the module declaration. Okay, so once this module declaration is understood, our next task is to learn what are the input output declarations, in out declarations, net declarations. Net declaration already we know. Variable, parameters, functions, tasks, concurrent statements, how to declare all these. Okay, let us see, for example, input output declaration syntax. Input output declaration syntax. Input output declaration syntax. So here, as we have mentioned in the previous example, input identifier, input identifier 1, identifier 2, and so on. And similarly output identifier is nothing but a variable, 1, identifier 2, and so on. Okay, when you are having an array, suppose instead of having a single bit, if it is an array, that also be declared here only. Okay, and if any in out signal is there, in out, again identifier 1, identifier 2, and so on. Okay, and suppose, as I said, if the input bit is having an array instead of a single bit, if it is an array, input MSB size to LSB. Okay, suppose if it is 4 bit, then 3 down to 0. Okay, identifiers which are having that array, identifier 1, identifier 2, and so on. Okay, and similarly same is the case with output, same, and in out also. Okay, if it is an array, for array, this is for array, this is for array declaration, array declaration, this is for single bit declaration, single bit. Suppose for 4 bit, for example for 4 bit, the size should be input 3 down to 0, a comma b. That means a and b are 4 bit size which are having 3 down to 0. That means nothing but a3, a2, a1, a0, b3, b2, b1, b0. That is the meaning of this one. Okay, so this is what input output declarations. In the next video I will explain few of these concurrent statements like um, while statement, if else statement, case statement. I will explain some of the procedural statements also in the coming videos. Thank you.